Okay, so guys, I'll wait for up to 5 minutes for you guys to join in and then I'll begin the session. The audio is clear, right? Everybody can hear me? Okay, so today's session will be covering basics of shooting. In Unity, there are two main kinds of shooting. One is prefab oriented, and the other is done through raycasts. You guys already have an idea of what a prefab is. We had discussed it in the last two sessions. We'll be discussing both of them. Before you begin today's session, open up Unity and import the standard assets package. I'll be using the first person controller there so that we don't have any differences in our movement code. It's easier for all of us to sync it better. So for now, I'll just create the ground and the frame of reference here. So for now, I'm just creating a few materials and just keeping 2 to 3 cubes, which will act as targets for our shooting. You can create whatever shape you want. It's not going to be a challenge. So as I told you, I'll be using the FPS controller, which is provided by Unity. Just a few changes in the naming, and so as we talked in the previous class, using the standard assets package, if you use the first person controller, we can move around pretty easily. And yeah, we'll be using that to synchronize movement. Since we discussed it last class, I don't think we need to teach it again. So as I told you, today's topic will be shooting. So first we'll begin with shooting using the prefab system. This one is relatively outdated and is not used as much or as frequently as the Reka system because that's objectively better and provides you with a lot more information as compared to the prefab shooting. So when we shoot using prefabs, you can see that we basically first define a rigid body bullet, and this is basically a small prefab which we'll have to create. So let's say we create a small sphere and we make it a prefab. Let's rename it as bullet, and this will be the bullet that comes out. So we need it to be a lot smaller. Maybe something like. So this is what our bullet will look like. You can see it's not much of a bullet, but it's fine, I believe. So yeah, we have it saved. Then the script is very simple. Now, we talked about what start and update do in the previous class, and if you see and you know most of what all of these functions are used for. So I'll talk directly about the function. So here, so if input dot get button down. So what get button down does is it checks whether the button for which we have given the name here has been pressed or not. And if you hover your mouse over, 1 second. Yeah, so get button down is basically used when we want Okay, I don't have. One second. Yeah, so I'll just open up the script in Visual Studio. Yes, so I opened up a new script named firing. Just use this code. So the prefab shooting is relatively simple to understand since we have already worked with prefabs before. But once you get the hang of raycast you will see that prefab shooting is a much worse choice. So what happens here is we have a public rigid body bullet, which is basically the one that we created here. We need to attach a rigid body component to it. So yeah, this is the we'll use the editor to assign bullet here, and we have a public float speed, which is the speed with which the bullet will travel. So as I was saying, get button down. It returns true during the frame the user pressed down the virtual button. So a virtual button is defined in Unity as a button which is synced with your input. So here fire one is already synced with the joystick, with the mouse and the keyboard. You can see the editor preferences for these in should be somewhere here. Anyway, the button preferences are basically already defined, and you can see that basically fire one here is used for left mouse button. You can also use get mouse. You can also use get mouse button, I believe, for mouse button down. It has the same effect, and in this you don't need to assign the value here. And 0 is for left mouse click, 1 is for the right mouse click, and the middle mouse button for the middle mouse button you can enter 2 here. So I want to shoot using the left mouse button. So what happens is the instantiate function here creates a game object, which is the game object that you mentioned here, with this position, this rotation, and here as rigid body tells you that you don't need the entire game object, you just need the rigid body component of it, and that will be enough. And then after that, what we do for the bullet is we just give it a particular direction. Here new vector 300 speed, you can also use forward and multiply it with speed. So forward into speed, that also works. But yeah, I don't use prefab shooting and I don't want to discuss it much, but this is the basis of it. Basically, you will create a new game object. Every time you use your left mouse button to click, you can instantiate this game object, and then immediately after instantiating it, you can give it a particular velocity, which you can use this formula to denote. And then once you're done with the bullet, since we don't want it to be existing forever, we can destroy the bullet using destroy instantiated bullet. So, and then we can give a particular time. Let's say we want to destroy the bullet after 0.5 seconds. So zero point 0.5 f. Yeah, it takes float value, so you'll have to enter f after whatever decimal value you put in, because otherwise by default it takes it as a decimal double value. You have to convert it to float, and for that you can just type in f. So this is the amount of time it waits before destroying the game object mentioned here. You can either use this approach or you can use the approach which I prefer. Uh, So now we'll talk about using raycast shooting. So so basically, when you create a game object, it takes a lot more computational power for shooting than you need it to. And for most cases and most games, you don't usually see the bullet. So you don't, and you to be frank, you don't need to see the bullet. You just need to feel its effect. And this can be done using the raycast shooting. Here, you don't need a bullet prefab. So how raycast works is it uses simple physics based and ray based momentum. Basically, what you do in raycast shooting is the basic command. Okay, let's first just start typing it in. So we'll need an update function. Yeah, so under update again, when we get the left mouse button, so input is the class here, and get mouse button down is the is the function. You can use mouse button down for automatic and continuous firing. Or you can get mouse button when for sorry you can use get mouse button for continuous firing, and you can use get mouse button down for time defined firing. So since most FPS games usually use automatic bullets, we'll also use the same feature. So get mouse button down, enter 0 here, and under if, here is where we'll type in our code for shooting. Basically what happens. So how raycast works is you enter coordinates for position and a particular rotation, and then you enter a range. So a ray travels in the direction you have given from the position you have given for the range that you have defined. And if the ray is hitting anything in the middle, basically, then the ray stops at that particular point, and you get information of the object it has hit. So the code for this is physics.raycast, and parameters are so we need since we are going to attach the shooting script on the player, but we want to shoot in the direction of the camera. So we'll need a reference to the camera here. We can get that using public game object camera or shooting camera. So shooting camera. So you can see here what the parameters are. So vector3 dot origin, this is the starting point of the ray. Vector3 dot vector3 direction. So this is the direction in which the ray will travel. Float max distance is the maximum distance or range that will travel up to. So we'll need a range component as well. We'll be defining these values in the editor, so we don't need to initialize them for now. So our initial position is shooting camera dot transform dot position. This is our origin. Our shooting direction will be shooting camera dot transform dot forward, since we need to shoot in front of the camera exactly, and our max distance will be our range. So if you just use this, you won't be able to see what happens, but something will happen basically. So physics.raycast here will give us information of how it will travel. And since this is a statement, it returns true if the ray hits something and false if the ray doesn't hit anything. So how this function exactly works is we need another variable here as well. So here we need a raycast hit. Okay. This will come under if. So this if statement checks if the ray that we have shot hit something, and if it hits something, we store the output for that in hit here. So hit is an object of class raycast hit. Raycast hit is again another unity defined class under under physics class itself. So raycast hit gives us information of the collider that it hits. As we talked in earlier classes, all these planes, cubes, they have colliders which you can see here. So it will give us information of the collider, and using that you can refer to the parent's transform or the name, whatever. And this makes it really useful to use raycast shooting, because you can get information of the object you hit. And for example, if you're hitting another player using raycast, you can directly get information of the player and decrease that player's health. Same for enemies or destructible objects. And this is why most people prefer raycast shooting. So for now, let us just print the name of the object that we have shot. So debug.log here is used to print statements in the console window, which is here. So you'll see a statement here which will be printed whenever we hit an object. So for now, we want to print the name of the object that we have hit. So we can use hit.transform.name. So the collider itself would not have a name directly. So we go to the raycast hit object that we have. This is where the output is stored in. Then we go to the transform of that object and we use the name that the transform is given. That name will be printed here. That name will be the exact same name as the name the object is given here. So let's just give it a second to compile, and let's attach the script to the player. Just shoot it. Yeah. So this is, and the shooting camera will be our camera, and we'll give the range for now as something very high, let's say 300. Uh, I'll talk later about why range is so important if you are giving it even so large values, so that it might not make a difference. So as you can see, when I hit the plane, it prints out plane. When I hit this cube, it prints out target. And when I hit this cube, it will print out cube. And as you can see, there's a lot of print statements going on, which are indicated by the numbers that are attached here. You can see these numbers. This is how many times the bullets have been shot. So we need to keep a control on the number of bullets that we are shooting. I'll teach you how to do that. But I hope that you guys have figured it out now. I'll just stop. Any of you have any doubt regarding this? So far, this is all the code that we needed or used. Okay, so before we go ahead, we need a reticle or a crosshair to aim at. Because as you can see, when I was moving around, I couldn't really see clearly where I was shooting. So for that, I'll just add a small image. So add a small image under player. When system is here. So under image, by default, Unity has something called a knob, which is good enough for us for now. For aligning it, just switch to 2D and click on the image. Yeah, you can see it selected, zoom out. So as of right now, the image is going to be very large. This is going to be, this canvas denotes your entire screen size, and this is the image size on that. So this image will be extremely large. So let's just make it something smaller, let's say 10 into 10 cross 10. And so now if you see, you can see a small white colored knob, and this will be exactly where I'm shooting. Since since the canvas is attached to the player here, it focuses on the rotation the player has and rotates the image accordingly. So you don't need to write any code for changing the crosshair direction or syncing the movement with the player, since it's a child of the player. So now that we have the crosshair fixed in as well, let's talk about how we manage the how we are going to manage the time and the number of bullets that we have. So as of right now, we have infinite bullets and the time between firing is 0. So let's change both of them. Let's say that we have a fixed number of bullets, which will be our initial bullets. This will be the maximum number of bullets that we have. And we'll denote our current bullets by a different integer called current bullets. So when we start up using the start function, at that point we can initialize our current bullets as equal to initial bullets. And here we can check that if we our current bullets is more than 0, only then we can shoot. So let's say, so let's just go ahead with this. So let's say that initially we have something like 40 bullets. Okay, before we start playing, a very handy tool that we have in Unity is you can see that I marked the bullets private, so current bullets as private, so we can't see it in the editor menu. But if you want, if you when you're making the game and you want to see certain private variables in the editor, even though they are private, you can switch from normal mode to debug mode. This will allow you to see the private values, but as you can see, you can't edit these values. So this will help you distinguish between what values are private and which values are public, which values do you need to change and all of that. So as you can see, initially the current bullets is 0. When we start up a game and enter into play mode, our current bullet changes to 40 and you can see, sorry, every time we shoot, we need to decrease our number of bullets. So you can see that if I shoot, so there will be exactly 40 outputs here. And now if I'm shooting, I'm unable to shoot when I uh, click on my left mouse button because I don't have any more bullets. So first thing we need to do is enable reloading. After this, we leave that for now. First, we'll talk about the time between shots. So let's say public int, let's say we have a particular fire rate. This fire rate will be the number of bullets we can fire in a second. You can also define a time and it won't be a big challenge to cover up. So for this, what we need to do is we'll talk about something called an I enumerator. So in Unity, it's very easy to make the game wait for a particular amount of time, but you can't do this using normal functions. You have a special function type defined as IEnumerator, and the code to start it is also quite a bit different. So first we'll give it the name IEnumerator, and since it's a shooting function, I'll just name it as shoot. You don't need to define a public. Basically, you don't need to define an access specifier or a return type. IEnumerator is in fact the return type of the function. This return type tells you that the return value will be in real time or in basically game scale time. So for this, you have a particular syntax. So this is just syntax. Don't worry about what exactly it does. You just need to use the same syntax every time you want the game to stop for a while. So yield, return, new, wait for seconds. This and then one by fire rate. So this is our entire shooting code. So I'll just shift this inside this IEnumerator, and here we'll call IEnumerator. So when you call IEnumerators also, it's not the same as calling normal functions. There's a different kind of call. It's quite similar, but to call an IEnumerator function, you need to have something called start coroutine, and then you need to type in the function. So shoot, yeah. So now every time before shooting, it will wait. We want it to wait after shooting. So this will come at the end. So every time this function is called, at the end, it will wait for 1 by fire rate time. But yeah, we need it, and since 1 by fire rate in integers will always be 0 if fire rate is more than 1, we need to convert this value to float so that it knows we are talking about a float value. As earlier, we need to write 1.0f. So this is how the code is going to work. But before we go ahead with this, we need to have one more change in our script. We need to, so basically what will happen now is every single frame, the update function will be called and it will check if your mouse button is clicked and if your current, if the number of bullets that you have more than 0. If it is, then it will call the coroutine. And every time the coroutine is called, it will wait for this fixed amount of time. But there's a chance that if this waiting is happening, another coroutine is called. So the same function can be called twice. And in that case, our waiting time will become useless. So we need to make sure that once the function is being called, it is not called again. So I am defining a Boolean. A Boolean is a data type which has only two values, true and false. I'm naming it can shoot. So initially we are able to shoot. So when we start the game, we should be able to shoot. So I'll declare this as true initially. And then when I'm checking this, we don't need this any longer. We can just check if we are able to shoot. If we are able to shoot, then we can start the coroutine shoot. Again, if the number of bullets we have is less than, if the current bullets that we have is less than or equal to 0, then we should not be able to shoot. At that point, you can turn can shoot is equal to false. Again, when we start the I enumerator, at this point we need can shoot be equal to false, because at this point we are shooting, so we should not be able to shoot again. And once we have waited for the defined time here, then we should be able to shoot again. So I'll just declare it true over here. You can put this value anywhere before this return statement, and the reason for that is once this wait for seconds is happening, at that point no other code executes in the script. So uh, the script may be called again and the function may be called again, but the script as a whole stands still for while this function is executing. So at this point, if can shoot is false, this value, a new IEnumerator function will not be called and we will be able to fire easily. This will help us put a cap on our fire rate. So let's just let the script compile first. Yeah, now you can see can shoot is here and fire rate is here. So let's say I want to be able to shoot just 2 bullets every second. As soon as I press play, you can see that can shoot is checked, which means that as of right now it's true. If I shoot, it becomes unchecked for a while. And while it's unchecked, even if you left click, you won't be able to shoot. At that, you can see that I'm able to shoot exactly 2 bullets a second. You can see that it becomes unchecked and checked immediately. If you hold your mouse button down, you can see that bullets are decreasing, but you can't see can shoot toggle. It is toggling. It's just that as soon it's happening in a frame, so you won't be able to catch it. And again, when your current bullets turns to 0, you are not able to shoot no matter what. So let's put in a reloading option. Usually most games use a particular key for reloading. I'll use the same here. So I'll reload using the R button, R key on the keyboard. So for referring to any key on the keyboard, you can use input dot get key code, get key down, and in get key down you can use key code dot R. So what this does is it checks if you got the R key in the keyboard. Again, if you want to configure the game for joysticks or for gamepad controllers, you'll have to use something similar to what we did in the prefab script, where you use the get button down. So in that case, you can go and explicitly define which input configures which one. And so here we are going to configure it only for the keyboard. So let's just talk about this for now. So when we reload, again, we need to have a particular amount of reloading time. So before we can shoot again, so public int reload time. And again, since we need to wait for that particular amount of reload time in the game, we need to call another IEnumerator function here. So let's rename this one as IEnumerator reload. And in this, we'll need to wait for the same syntax again, yield return new wait for seconds. So a few of you might be wondering that there's this function that pops up, which is wait for seconds real time. And what's the difference between wait for seconds real time and wait for seconds? So what wait for seconds does is, if your game is paused, or basically when you pause the game in Unity, there's something called the time scale of the game. And an IEnumerator is the same thing as a normal function. The difference is that IEnumerator is the return type of the function. And here it is returning a time wait, basically, which is why it's yield return new wait for seconds. IEnumerator is just the return type. And yeah, as you can see, if I remove the statement, then it will give an error here, because you can see that not all code paths return a value. It should return a value, and the return type is in real time. So that's what an enumerator is, just the return type of the function. It's nothing different. But the importance is that it's really helpful when you want to create a time gap in the function. So as I was talking earlier, the difference between wait for seconds and wait for seconds real time. So here you can see it says suspends the coroutine execution for the given amount of seconds using unscaled time. And if you go here, you can see using scale time. So in Unity, you can define a time scale. In a few games, you would have seen that you can you can pause the game, or you can make the game go really fast or really slow. Basically, using power ups, you will get a slow motion thing and all that. So in Unity, you can change time using a defined time scale. So when you pause it, you can just set the scale of time flow as compared to real time to be 0. So even though real time will be passing, time in the Unity game will not be passing. By default, if there is no change made to it, that real time and scale time is the same. But you can scale time to be half, twice as much, whatever value you want. We'll cover that in later sessions. So let's just cover up the reloading for now. So now we needed to wait for reload time. Uh, don't worry too much about the syntax of yield. Yield return here is a combined statement. Don't worry too much about the syntax. Just remember it. Trying to learn this particular line of code won't help you much. Um, Basically, yield tells you that even though you are returning something, you want to stay in the function and continue execution. If you type just return here, it'll either give you an error, or it'll exit the function after that. So as you were seeing earlier in the shoot function, if I remove yield from here, can shoot equal to true will not be executed. It will stop the function execution right here. But since we wanted to run even after even since we run the code even after this particular waiting to run, we use yield over here. So in reload, what we need to do is we need to first, let's call the coroutine here, start coroutine reload. So what we need to do in reload is we need to change. We need to configure the number of bullets. While we are reloading, again, we should not be able to shoot. So can shoot equal to false as soon as we enter. Then we can change the current bullets to the initial bullets. This is why we define two parameters for this. And once we are done waiting or reloading, we can use can shoot equal to true. Yeah. So current bullets should become minute bullets after we have waited for reloading time. So this is all we need for reloading. And again, this way the reloading will happen when we press R. So let's just test it out. Okay, let's give the reload time as something like 2 seconds. Let's increase the fire rates. So once we start shooting, you can see that it's still not as fast as it was earlier because there's a defined fire rate. And once we run out of bullets, first, once we reload, you can see that the bullets are refilled. You can reload using R and you can shoot. Again, something that might happen is if you are shooting, if you press R and if you press R again, you'll reload twice. Uh, the same reason why we used the can shoot over here. Even though we defined a wait period over here, we use can shoot in order to make sure that this function is not called twice. You can define a can reload boolean. I'll not do that here, and we'll just go to the next part of it. So, any particular part or aspect of shooting that you would like me to cover after from here? Okay. So a few more things that you can do is you can show the shooting effect. As of right now, when we shoot, you can see the name being shown here, but you can't really see the bullet or any effect of the bullet. Uh, so in order for us to in order for us to show that, that's really simple. Basically, what I'll do is I'll create, sorry, what exactly do you mean by animate the bullets? Most FPS games actually don't show you the bullet moving, and they also use Reka shooting. I'll show you the effects they put in to make it sound and make it feel like there is something that happens. So let's put in an audio source and let's put it under player. This will be our audio for the bullet sound. So let's see. So I already have a bullet sound and then the impact the bullet's impact effect saved. Yeah. So this is the bullet sound that I'll be using. Basically, to create the bullet sound, just create an audio source. You can create an audio source here using right click on player and audio source. In the audio source, where you can here you can see audio clip. So here just drag the audio that you want to play and check off play on awake because you don't want it to play unless you're shooting. So how we trigger this is going to be really simple. Under under our script for Rekha shooting, just declare another public audio source and let's just give it the name sound. And whenever we shoot, as soon as we shoot, we need the sound to play. So sound dot play. That's it. And then go back into the editor. Yeah, here you can see sound appears and just drag this audio source here. So every time I shoot, in here a particular sound playing in. One second, this was, okay, sorry, this was the audio source, right? Mm, it's- yeah. If you want to put physics into it, you will need the prefab shooting material prefab shooting script that we discussed in the start. But if what kind of physics? If you can add, yeah, I mean, if you want to add physics, you have to treat the bullet as a rigid body, instantiate it and destroy it immediately. So if you want to play sounds and if you want to just play sounds and effects, then you can use this. You can hear the bullet sound playing now whenever I shoot. Similarly, you can add stuff for reloading, and if you want to add gravity, you can't use Rekha shooting. Yeah, if you want to use gravity, then you can't use Rekha shooting. You'll have to use prefab shooting, and gravity will not really affect the bullet's trajectory as much as you think. And for how most games actually do simulate gravity is if you talk about PUBG, when you scope in, you can see there are different levels which are marked, right? At each point, you can basically when we one second. Basically, for enabling that under physics.raycast, when you are shooting camera.transform.position, you just see how far the object is, and you can change this starting position based on that. So you can alter the trajectory of the bullet using that. You can change the starting position of the physics raycast here based on how far the object you think will be, and yeah, on based on that you can cause changes to the object. Based on that, you can cause changes to the trajectory of the bullet. Okay, continuing. Another common effect that we see in most games is scoping or zooming in, basically, you can say. Uh, so how to enabling that in Unity is extremely simple. Although you can say there are two ways to do it, I always prefer the easier way. The more complex way is that you have a camera with a different zoom or a camera which is a little ahead of you, and you switch to that camera, and that changes the scoping amount. That's not going to be extremely useful, and that's not how most companies and games do it. uh, what we are going to do is going to be extremely simple and will be the exact thing that uh, it will be the exact thing of how it's stimulated exactly. So I'll be using the right mouse button for zooming in. You can choose whatever you want. So get mouse button, and here You can enter one for the right mouse button. So we should be able to scope in whether or not we are shooting. And for this, all we need to take our shooting camera, and then we have to type in get component. We get the camera component basically. Camera. And we change the field of view of that to 30. So you can see that the field of view for the camera here, one second, just let the script compile. Yeah, so if you go into the camera, you can see that there's something called, the field of view here. So basically, let's say you, yeah. So once you have the camera view, if you change the field of view, it changes how much of distance it covers. So it enables you to see better if you change the field of view. Initially, the field of view is 60. So for a 2x scope, you'll change the field of view to 30, which is 60 by 2. Similarly, for 4x, you can use 15, and 8x, you can use 7.5, and so on. Yeah, once you're done with the field of view, so you need it only when the mouse button, while the mouse button is pressed, and as soon as it's not pressed, you need to set it back. So if not of input dot get mouse button 1, again you can create this value to be variable uh, using variables, but since we are going to have just a 2x scope, we can use this value itself. Yeah, so now when I press right click, it zoom, you can see the 2x effect. Although it's not actually being done, but this is how games do it. And while you keep the right mouse button pressed, it'll keep you scoped in. And yeah, this is how most games do it. You can again change the field of view to something a lot lesser to change the scope view. So let's say if you use something like 10, it gives the effect of 6x scoping. Yeah, you can see it's extremely close up. So now we'll talk about something. Now we'll talk about something else as well. I'll just change the field of view back to 30. And this is going to be extremely important. This is how friendly fire is avoided in most games. So as you can see, if I get it too close, if I look straight down and shoot the bullet, it shows that I'm hitting myself here because it shows player. We want to disable that because we don't want to be able to shoot ourselves. So in order to disable this, uh, go to the player, and under that you can see there's something called as layer. So under layer, click add layer. You can select any other layer, but it's best if you're using a separate layer. So this layer works the same. To decrease the field of view gradually, you can use a for loop or something quite simple as that. To decrease it gradually, you can just use a simple for loop where you decrease it. Like let's say you want to decrease it by 3 over a period of 1 second. So we'll have to use a coroutine though. So let's say that you want to scope in but you want to do it gradually. So let's call the coroutine called zoom. I enumerator zoom for, and let's say that you want to do it for over or 10 times over 1 second. So for each time since you want to do it over 1 second and you're doing it 10 times, yield return new wait for seconds point one f. Again, you can put in you can put in a variable here by 10 if you want to do it in that way. And here you can set the field of view shooting, yeah, this particular value. Since we want to decrease it by a total of 30, we can just decrease it by 3 every time. So this will give the effect of you zooming in over a second. Yeah. Yeah, the error is occurring because when once you leave it, the function is still working. Here you'll have to use booleans to make, and you'll have to use the same code for zooming out as well. So zoom in and zoom in have to take the same amount of time, and you have to make sure that once you leave the button, it doesn't like it once if a particular coroutine is running, you don't allow this to run. So you can have something called a can zoom in boolean over here to avoid this. Let's undo this. The reason for the error over here was that if the I enumerator was actually running, but uh, at the same time the field of view was being made 60, so it was decreasing 60 to 57, 60 to 57, 60 to 57, and so on. So you have to make sure that if this function is running, then this function is not running in that case. Okay, coming back to what layer was. Yeah, so you can see that as soon as you click over there, it allows you to create a new layer. So I'll select that layer now, and then it gives you an option that you want to set the layer to player for all its child objects as well. Yes, because you don't want to be able to shoot any part of ourselves, and any child object of the player are a part of the player. So now we have most of it ready. What we need to change over here is we need to create a new something called as a layer mask. So a layer mask is again another class, and this is an object. So what layer mask does is it allows you to select which layers the raycast will hit and which layers it will not. And the Unity already has it configured. So all you need to do is add a parameter called layer mask. And again, we'll be defining layer mask in the Unity editor. So we don't need to define anything over here. Yeah. So let us compile, and yeah, you can see over here initially nothing selected. We want to be able to hit everything but ourselves, so we just select everything and deselect player. And now if you try to shoot yourselves, it will go through you and just hit the plane. If you think that this doesn't work as well as you want it to, you can try it on something else. Like let's say you want it to pass through target. Get autoplay first. So this is the target cube, the one in the air. We'll change the layer of this to player as well. And you can see that even though I target player specifically, nothing pops up. If I change the layer back to default or any other layer, you can see that now it works. So this is a very good way to avoid friendly fire or to avoid objects which you do not want to hit. Uh, Now, the reason that we made the script in such a configurable manner is very simple, and one that will probably help you a lot in the future. Basically, when you have this out of these, the only object, let's say that you have an array of guns or you have multiple guns, and for each gun you have a different range, different kind of damage, different number of bullets, and all of that. The only object that stays constant is this. So what you can do is whenever you switch guns, let's say that you have a function called switch guns. As of right now, we have just the one, so it doesn't matter. But every time we call in this function, let's say that you use something like F or something like Q to switch between weapons. So what you can do is you can define a custom class called gun. And in that gun class, you can define these values such as range, initial bullets, layer mask, fire rate, sound, the current bullets, and the reloading time. And you can use the same script for different guns just by changing these parameters. Like let's say that initially I'll use the gun which I have defined, but when I press Q, the gun changes values and the number of initial bullets is 20. The number of current bullets will become the same as the number of initial bullets. I'm hard coding it here, but you can see that you can again define variables and change it as much as you want. You can define, in fact, you can even define a different script for gun. All it does and all that does is define these parameters and how they are interrelated. So let's say that the reloading time is 1 second and that the fire rate is zero point 0.5 f. Sorry, it has to be an integer. So let's just say that the fire rate is 1. And let's you can again enter audio sources. This is all the change I'll be making for now. And you can see that this will allow our code to work smoothly and function properly, even even though we are changing guns. So for now it works, and you can see all the values over here, the fire rate, current bullets, and all of that. So yeah, once I press Q, you can see that all of these parameters are changed. The number of initial bullets changed, the number of the reloading time, the fire rate changed, and all of that. Any other component that you would like me to cover up today? Otherwise, we'll close the session here. Also, one of the features that Unity offers is that you can get your own images and then you can use them in Unity. So let's say that while the knob is fine, we need a proper crosshair. So we can use something other than, yeah, we can use one of our own. You can get any image of the internet basically and use that. Not be an issue. Yeah, you can use any image that you have taken. I think you can't use a PNG format. Other than that, it should be fine. Let's debug back. Should- Yeah. So I changed the knob to a crosshair. And when you download images, one thing that you have to make sure of is that you check if the background is white or whether it is transparent. Transparent backgrounds are going to be preferred because for obvious reasons that you don't want the crosshair on any image to be. You can put a model of a gun as well as a crosshair sprite here. So I didn't use a gun because I didn't think it was necessary, but yeah, you can get in any gun if you're making a proper game. So I'll just show you. I do think okay. One of the guns that I use in a few of my games is sci-fi. Yeah, I would recommend this. This is if you want, I'll share the link for this. But you can see that it's really easy to find out where it is. This is one of the guns that I use. This is a 3D. Okay, so in the prefab mode, when you use prefab shooting, you have to manually destroy the bullet. When you're using raycast, there is no bullet actually. It's just a simulation of how a bullet would travel. The ray stops after it hits the first material. Basically, as soon as it hits the first collider, it gets. So if you're uh, mainly if you're like yeah basically if you want to make it extremely realistic then okay yeah sci-fi gunlight prefabs. Yeah, so you can see there are different types of guns here with different colors. You can get in anyone. So let's say I use this one, transform 000. So yeah, you'll have to go and yeah you'll have to go under play mode and arrange the gun. You can, and a raycast actually does that on its own. Uh, but when you're using prefab shooting, you can actually make use of reflection and its parameters. Like when you hit a wall, you can make the bullet bounce off the wall and work the physics. Although this is extremely computationally expensive, but it is really useful. As you can see here, the gun won't be aligned at first, and if you look around, the gun might disappear. So once you have so make sure that the gun is made a child of under the camera and then align it with the camera. So yeah, you'll probably want it at a particular location. You need to go under play mode and arrange the gun okay, another thing that I forgot to cover, uh, in cameras when you can see this a particular thing called the clipping plane. So this is the point after which after which and before which the camera stops rendering or stops showing you what is present. So basically if you change this to if you make it as small a value as you can, you'll be able to see things which are closer as well. But if you increase the value, like if I make it something like 100, you can't see anything in the preview. So make sure that the clipping planes which are near are set to as low a value as possible. The reason that these exists are that this particular clipping plane exists is because let's say when you're playing something like a racing game and you want the perspective to start from a little point after the camera, then the clipping planes are really useful. They're not really useful from a first person shooter perspective. So let's just arrange the gun a bit. A couple, I'll cover just one more part today and then you guys can leave. So what I'll be covering now is now you can hear and you can feel the effect of the bullet. Like you can see that the shooting is working, but you're not able to visualize the bullet's trajectory, which is something which you'll need necessarily in a game. Like you want sparks or a blood effect or something like that, which shows up when you hit the bullet with something, right? So for that, what you can do is uh, you can use particle systems. So again, you can either import them or create your own. So I'll just create a small one. So to create a particle system, again, go under create effects and then particle system. Let's rename it as shooting effect. Okay. Yeah, so this is how the particle effect normally looks. First off, we don't want it to loop. We want it to run only for a short while. Then we want it to be running only for a very short duration when we are using shooting. So let's set the duration to just zero point 0.1 seconds. We don't want them to play automatically, so we'll disable play on awake. This you can try out most of the settings here. They're quite simple. Start delay is null, start lifetime, start speed. Yeah. Okay, so this is the maximum number of particles that will be there. This auto random seed means that there will be a random number of particles, but this will be the maximum. So let's say since we are just emulating a small effect, we'll name it as 50. Then emission and shape, you can see these values. They are not going to be extremely tough or something new. Okay, here you can change the color of the particle. So since you're shooting something like this would look good, only maybe a little dark. Yeah, so now what we want to do is we want to show this particle hit where it hits the bullet. So the code for that is very simple. Basically, you need, as we did in prefab shooting, you need to create an object at the point where it hits. You can get the information from the raycast hit object hit that we had created. Just one second. I don't remember the exact syntax for it, so just give me 1 second. Yeah. So this two lines of code is all you'll need for the for showing the effect of the bullet hitting at any particular point. So you need the bullet to show that effect only when it does hit something. Yeah. So what do these values mean? 1 second. Yeah. So impact effect and impact geo are both going to be game objects. You can give whatever name you want. The name's not something that matters. Just make sure that the names you give here match the names over here. So what the instantiate function asks for here is the effect, the game object that you want to instantiate or create, at what position you want to create it, and since we don't want it to, uh, since we want it to create at different rotations based on how and where we hit what object. Hit dot normal here gives us the direction of the normal of the object we have hit, and quaternion dot look rotation is used to compute the rotation between that point and the rotation that we have. So basically, this will see the camera's rotation, compare it with the rotation of the collider that we have hit and the point that we have hit it on, using the same ray, it will find the direction that is coming that the direction of the ray, and in the opposite direction, it will show this particular effect. So this might be tough to understand at first, but it's really simple once you get it. And yeah, it's basically the difference of the initial rotation or the final rotation minus the initial rotation. That's it. So now let's just assign this object, and I believe we'll be good to go. Let the script compile. Yeah, you can see impact effect here. So I'll just choose shooting effect over there. Yeah, I think there's some issue with the effect. Okay. Yes, so we need to set the duration to something a little more flyer. You can always get these particles effects online, and yeah. So basically, whatever changes you make here will automatically sync there. That is never going to be an issue. Okay. Uh, I just check. Get back to you on this. You working? I'll get back to you on this, but yeah, this is basically how it's done. I'll just check it and see why this is not working as it should. Uh, don't worry about this. Okay, okay. Should be outside. Should still have worked. Let's see. I'll get back to you on why this the effect isn't working, and I'll make sure that I show you this via script or something else. This covers our session for today. Unless you have any doubts, I'll close it for now. I'll close it for today. Yeah. So I'll close the session for today. Okay, so make sure that you have play on awake initialized to like basically initialized to true over here. Otherwise, you will create the object, but it won't play. If you don't want to do that, then you can just untick this and you can do this as well. It's just impact geo dot play. We get component. Just use impact geo dot get component particle system dot play. You can fine tune it to make the particles smaller and last for lesser time. Change the colors as you want. If you want, I'll give you a better particle system as well. I do believe I have it stored somewhere. That's the session for today. Thanks for attending. I'll see you later. I'll see you in the next session.